Okay, so I will now do the Chapter 3 review worksheet. It's a nice little review of the major concepts of Chapter 3. I encourage you to work this worksheet and kind of pause the video after each question and then check your work. Certainly send me any questions you have, but let's look at this. This says a restaurant owner wishes to create a model to show the relationship between the number of customers he has each day and the number of rolls of bread that are used that day at the restaurant. He takes an SRS of 12. That'd be a simple random sample, which can be an issue next chapter. Simple random sample of 12 days and gets the data below. Identify the explanatory and response variable, then create a least squared regression line for the data and evaluate the equation by creating a scatter plot R value residual plot, which even if it didn't say evaluate by scatter plot R value residual plot, you would do it. If it said evaluate the equation, you would do it by looking at the scatter plot R value residual plot. So what I've done is I put these in list one in my calculator. We're given the raw data. So what I did was I hit stat and then hit enter on edit. And then in list one, I put the explanatory variable, which is the number of customers. And then in list two, I entered the response variable, which is the number of rolls. Okay, now it says to create the equation of the line. Well, okay, and I just identified the explanatory and response. There's the explanatory, there's the response. So let's create the equation of the least squared regression line. So the way we're going to do that is by hitting the stat button and then go to arrow over to calculate and go down to linear regression, number 8. And then my X list says list 1. If it didn't say that, I do second and hit the 1 button, put list 1 there. And then my Y list, my response variable, I'll put that in list 2. So let's pretend it didn't say list 2. I do second, hit the 2 button for that. And then frequency list, leave it blank. Store regression equation. I'm going to store it in Y1. And Y1, the shortcut for Y1 is on the F4. You could go F4 and hit enter to put Y1 there. Or you could do this. You could hit the vars button. So vars, Y vars, enter, enter. And that puts Y1 there. And so there we go. So there's my equation of my line. There's my R and my R squared. So I got the equation of the line right there, wrote it down. Always define your variables. X is the number of customers, Y is the number of rolls. And so to evaluate how good this line is, we're going to do the scatter plot, which that's just the X and Y coordinates. I'll show you how to quickly do that with your calculator. There's the R value, which I got off my calculator, the correlation coefficient. And then the residual plot, which I'm going to show you how to do. All right, let me show you how to do the scatter plot. So to do the scatter plot, we're going to go to the stat plot menu. And so I'm going to go second stat plot, hit enter. Now you notice only plot 1 is turned on. That's good. So I'm going to hit enter on plot 1. So, and I'm going to hit enter on scatter plot. Then my X list is in list 1. My Y list is in list 2. So I'll do second, hit the 2 button. And so we're ready to graph. I'm going to turn off anything that's in the Y is equal to menu. Good. So it won't go through my graph. I don't want to delete this. That's the equation of my line. But notice how the equal sign is highlighted. I'm going to hit enter on the equal sign to turn it off. And now you just hit the graph button and zoom 9. And there's the scatter plot. And so you can hit the trace button right here to get the X and Y coordinates of the points and arrow over to do your scaling using the X and Y coordinates. So that's how I got the scatter plot. So to get the residual plot, now by doing the regression command, it created the residuals for me. They're in the residual list, which is in the list menu. So to do the residual plot, you do second stat plot and hit enter on plot 1. And we're going to do a scatter plot with list 1 in the residuals. And we call that a residual plot. So we go down to the Y list and we're going to put residuals there. They are in the list menu. Now, if you didn't do the regression command, the residuals aren't, the right residuals aren't going to be there. And you're probably going to get an error message. So we'll do second stat, which is list, and go down to resid like that. And so there we go. And I'll just hit graph and zoom 9. And that is a nice residual plot. It's nice and randomly scattered, which is what we want to see. So we would draw that out. And once again, to get the scaling, hit the trace button, and you can arrow over and get the X and Y coordinates. And that way you can write down the scaling. And you just have to write down 2 numbers on each axis to get the scaling. Make sure to label your explanatory variables here, the number of customers, and then the residuals are on the vertical axis. And so the conclusion we would draw, we'd say, I feel great about this least squared regression line because of the linear and strong scatter plot, the very strong R value, and the randomly scattered residual plot. That tells us we got a good line. That's sort of the heart of the chapter. All right, R squared. All right, number 2 says what percent of the change in the number of roles is explained by the change in the number of customers? Well, the number of roles is the Y. So this is in essence saying what's the percent of the change in Y that can be explained by the change in X, and that's R squared. And of course, that one you got when you do the linear regression command, it tells you that. So stat calculate number 8, list 1 and list 2, store regression equation in Y1, and there's R squared. So about 94.06%. What R squared is. That's the percent of the change in Y that can be explained by the change in X. All right, so then it says number 3, interpret the slope and the Y-intercept. All right, so interpreting the slope, of course, we got this off of the line. There's the line, there's the slope, and there's the Y-intercept. So what the slope is for each increase in one customer, we predict that the number of roles will go up by 1.7997. So to interpret the slope, you're going to say for each increase, for each time X increases by 1, we're going the change in Y will in essence be whatever the slope is. Okay, but you got to say it in context. The Y-intercept is this. If there were 0 customers, we predict that the number of roles used would be 3.7338, which really kind of doesn't make sense in context, but that's number 3. Number 4, all right, how many roles would you expect if there's 120 customers? And what did you just do? Well, you just plug in 120 into the equation and you would get that, but this is an extrapolation because it falls outside of our domain of X values. Any X value that is below 26 or above 85, if you plug that into the equation, it's an extrapolation and should be viewed with caution. So you just plug in 120 there. All right, number 5, what is the residual of 64 customers? So you remember the residual is just the actual Y value. So the 20 is the actual Y value minus the predicted, okay? The actual Y value that goes with 64 customers is 132. So that's the actual Y value. So to find the residual, you say 132 minus whatever you get when you plug in that X of 64. And so we would get 13.085. So that's just saying this point is 13 above the line. Okay. And so the line under predicted for it by 13. They predicted we'd need 118.915 rolls. We actually needed 132. So sort of positive residual is. So we have that. So that would be number 5. Number 6. So in number 1, the standard error is 11.4, interpret. You'll always be given S. You don't have to find it. There's sort of a complicated formula for it. That's not a part of the AP Stats curriculum. And you don't have to use your calculator to find it. You should always be given S if you need it. It is the standard error about the line is the average amount predictions are off. So what we would say is in number 6, predicted number of rolls in this model will be off by 11.4 on average. In other words, predicted Y values will be off by that amount on average. So all right, number 7. All right, in number 1, another data point is added where the number of customers is 150 and the number of rolls is 80. What would adding this point to do to the slope and the correlation coefficient? What type of point is this? So what's happening here is, and so if we look at a scatter plot here, if we add 150 and 80, so 150 and 80 is going to be like somewhere down here. And that is what we call an influential point. And so the line was like this, very good predictor as we have discussed. But now this influential point, because it differs a lot in the X direction, it exerts more force than the other points. It's like someone with a long lever. It's going to yank the line down to it. So it's going to greatly affect the line. And in this case, it's going to greatly lower the slope. And the R value, which our R value is what, like 0.94, something like that, 0.97, about 0.97. This would knock it down to possibly in the 0.8s. Okay. It makes it go way down. So both the slope and R would go way down in this situation. So this influential point would pull the slope of the line down and lower the R value. All right, number 8. So number 8, when another restaurant does a study similar to number 1, they find that the number of customers varies with a mean of 57, standard deviation of 12.8, while the number of rolls varies with a mean of 160, standard deviation of 21. The correlation coefficient is 0.94. That means R is 0.94. Find the equation of the least squared regression line. All right, whenever they give you the mean and standard deviation of your two variables, you're going to use these two formulas here in essence. This one here for the slope, it's on your formula sheet. B is equal to R, standard deviation Y, standard deviation X. And then y bar is equal to a plus b times x bar. And so, and I just enter the given values. So B, it says the correlation coefficient R is 0.94. The standard deviation of the response variable is 21. And of the explanatory variable is 12.8. So that would be, there's the response, the number of roles, standard deviation is 21. And the standard deviation of your exits and the number of customers is 12.8. So I just multiply that out, get 1.5422. And so then, so that's B. B is equal to that. All right, so then you can find A by plugging into this equation. You know, one of the things we really like about the least squared regression line, it always goes to the point X bar, Y bar. It always goes to the point that the mean of the X is mean of the Y's. And so I just plug Y bar, that's the mean of the Y's, which is 160, and the mean of the X's is 57. So I plug those in. We just found the slope to be 1.5422. And so I solve this and get A is that. And so there's the equation of my line. And so there you go. All right. So, okay. Did I name? Yeah. So X, just to be thorough here, X is the number of customers. X is the number of customers. And Y is equal to the number of roles. Whenever you write X and Y, make sure you say what they are. I mean, I'd said that kind of earlier above, but want to write it again here. Okay, good. All right, good. Now we have a computer printout. So you remember on a computer printout, so let's read this context. It says a manager of a company wishes to model the relationship of the number of workers that show up each day and the time and minute it takes them to finish chopping all the wood that they need. The computer printout of the regression is shown below. All right, so what we've got here, this coefficient of constant, that's A. That's our y-intercept. These numbers next to A, that's A, we'll never use, just cross them out. All right, this coefficient of the explanatory variable, the number of workers, is B. So it goes A, then B, and we won't use these. We'll use these in chapter 12, but not now. We'll never use R squared adjusted, cross that out. So it's these four numbers you have to work with. What's the equation of the least squared regression line? Y hat is equal to A plus B. And so that would be Y hat is equal to 130 plus 1.7 minus 3.11 times X, where X is the number of workers, Y is the wood chopping time in minutes. So that's the proper way. Make sure to put a hat on your Y and make sure to define your variables. Number 10, when 15 workers showed up, the residual is 1.0232. What is the actual time it took to chop wood that day? Remember, all right, the formula for residual, the residual is equal to the actual Y minus the predicted. The predicted is what you get when you plug the X value into the equation. And so that's what I did. And so I solved it and I ended up with the actual Y is equal to 85.0732. So that's how you do that. Number 11, what is the correlation coefficient? In other words, what is R? Now realize R squared is that. So to find R, you take the square root of it, but remember it could be positive or negative. It has to have the same sign as the slope. So that's a little bit tricky. So for this one, you would say, since the slope is negative, R has to be negative. And so, and by the way, make sure and convert this into a decimal when you're finding this square root. And so that would be your R value. Okay, right there. So certainly a very strong negative relationship. And then we have a couple of problems from section 3.3. All right, a scientist notes that the number of beetles in a forest has been growing exponentially. In other words, it's in essence being multiplied by a common ratio pretty much. So notice in exponential equation, the X is an exponent, right? So through time, he wants to create a regression model. What transformation should he do to straighten the data? If it's exponential, you can take X and the logarithm of Y. You could do X, or you could do the ln or any base you want, but you have to take the logarithm of the Y values. That straightens exponential data. All right. And then for number 13, a researcher notes that the data he is working, the data he is working with is following a power law with Y is equal to A times X to the B. What transformation should he do to straighten the data? So in a power law, X is the base. Okay. X is the base of the exponent. To straighten it, you take the log of both the X's and the Y's. And there you go. That's your little review worksheet. If you got any questions about that, please let me know.